Hi there, welcome to my channel Mandu to Fundu. In this video, I'm going to discuss about the solution for best time to buy and sell stock problem. Let's look at the problem description. We are given an array of prices of the stock where prices of I is the ith day's price, and we have to maximize our profit by choosing a single day to buy the stock and then hold on to it to sell it in a future date, and we have to return the maximum profit that we can achieve from this transaction, and if we cannot achieve any profit, we have to return 0. Let's take an example 1, and in this case the input the prices is 715364, and so initially we buy the stock on the first day. The very next day price is less than the purchased price, so we will not hold on to that stock, we will sell it on the same day. And the second day we the purchase price, new purchase price will be 1, and then the third day we see the price is higher than the purchase price 1, so we hold on to it. And the at that point the profit we can make is 4. The third day, the fourth day, still it is higher than the purchase price, but it is not higher, the profit we can make from this transaction is not higher than the previous profit we made, so we will not update the maximum profit. But next, 6 minus 1, so which is 5, greater than the previously computed profit, so it we can get a maximum profit if we buy it on the second day and sell it on the 5th day. So that's why the output is 5. And the price's length is ranging from 1 to 10 to the power 5, and so at least one price it will have, and the value of the stock price is ranging from 0 to 10 to the power 4. So how we can compute the maximum profit? So let's use this same input as an example. So in this case the buying price initially we set at the first day price, and then we start from the second day onwards, and then we keep comparing the buy price and the next day price. We can compute the profit between this value and the buying price, and then keep updating the maximum profit whenever we see a maximum value. Let's look at the flow chart. Input for this procedure is the prices array. First we will have to initialize the buy price, next day index, and then the maximum profit variables. So the buy price will be set to the first day price from that array, and the next day index will be set to 1, and the maximum profit will be set to 0. And this is a simple for loop which I iterate over that prices array from the first index to the end of the array. So we check whether all the elements are processed. If not, then we will compute the current profit. Basically we from the next day prices and the last purchase price. We check the current profit is less than 0, meaning we lose here in this transaction. So we simply update the buy price to the next day price with the next day price, and move on to the next iteration. If there is a profit, then what we do is we compare that currently computed profit with the maximum profit we see so far. Whichever is greater, we update the max profit and then continue the loop. So this will go on until we process all the elements in the array, and then we finally come out and return the maximum profit. Let's move on to coding. First we initialize the buy price. with the value of the first element of the array. As per the problem description, the prices array has at least one element in it. We can safely access the first element. We initialize the max profit to 0, and then in the for loop the next day index will be starting from 1. Each iteration I compute the profit with respect to the last buy price. If it is negative, meaning we lose, so simply update the buy price to the next day price. Else we update the max profit. After all the elements are processed, finally we return the max profit. Now I am going to run this program. Okay, it's accepted. Case 2 is also accepted. Okay. Now I am going to submit this program. Okay, cool. Let's do the code walkthrough with sample input. I'm using this input for the code walkthrough. So initially the buy price is set to the first day price, which is 7, and then the profit is set to 0, and the next day index is starting from 1. So now we compare the price pointed by the next day with the current buy price. 1 minus 7 is minus 6. So we lose money. So we will be simply updating the buy price to the whatever the next day price is, and then we advance the next day index to point to this. So that is what we are seeing in this second iteration. So here we compute the profit with respect to the current next day price with the buy price. So we make profit 4 here, and we are not updating the buy price, but instead we advance the next day pointer to the next element in the array. So the profit we update is 4 because we update the maximum of the previously computed profit and the current profit. So current profit is greater, so we update that. And now we compute the profit pointed by the next day, 3 minus 1, which is 2. That profit is less than the previously computed profit, so we simply ignore that, and we simply advance the pointer to the next entry. So here we compute the profit. So 6 minus 1, which is 5. So the current profit we computed is greater than the so far seen maximum profit, so we update it. So from 4 to 5, and then finally we the next day our pointer advanced to the last day price, and 4 minus 1, 3, which is less than the current maximum profit, so we simply ignore that. And so the best day to buy the stock on the second day and sell it is on the 5th day. Let's do the time and space complexity for this solution. For this input, it has 6 elements in the array, and our algorithm walked through from the index 1 to the rest of the array elements. So it, in this case, it runs 5 times. So for the array of size n, this for loop run n minus 1 times. So it's the time complexity is order of n. So this program do not allocate additional space with respect to the size of an input. It just simply uses only 3 variables: the buy price, max profit, and current profit. So the space complexity is order of 1. Thanks for watching this video. Have a great day.